Ever wondered what's actually inside an industrial pressure sensor? Today, we're opening up a Siemens QBE2002-P10 pressure transducer to see how it works and what makes it reliable in real-world systems. This device is designed to measure pressure in liquids and gases, typically up to 10 bar, and convert that into a clean electrical signal, usually 0 to 10 volts. But inside, it's much more interesting than just a sensor. Let's start from the bottom. This threaded metal part is the process connection. This is what screws into your pipe or system. Right above it sits the pressure sensing element, typically a ceramic diaphragm. When pressure pushes on it, it flexes slightly. That tiny movement is where the magic begins. This sensor uses something called a piezoresistive principle. That means when the diaphragm bends, it changes the resistance of tiny embedded resistors. Those changes are extremely small, but measurable. So pressure, then mechanical deformation, and then electrical resistance change. Simple idea, but very precise. Now, look at this exposed circuit board. This is where the raw signal gets processed. The small ICs amplify the tiny resistance changes. Filters clean up noise, and the signal is converted into a stable output, like 0 to 10 volts. Those copper pins at the bottom connect the sensing element to the electronics. And up top, you can see the wiring. This carries power in and the signal out. Once you open one of these, it's basically done for. They're factory calibrated and sealed. So this teardown is purely for learning, not repair. So that's what's inside a pressure transducer. Mechanics, physics, and electronics all packed into one small device. If you want to see more industrial teardowns like this, hit subscribe and let me know what we should open next.